Okay, welcome back, Math 10 students. We're going to do lesson 1.4 here, all about negative exponents. This might be completely new. Your Math 9 teacher may have shown it to you, but either way, we're going to go from scratch with this. So we're going to begin with just evaluating some powers just to really see what's going on here to help understand the negative exponent. So we have positive exponents here, 2 to the 4, which of course is 2 times 2 times 2 times 2. It's repeated multiplication, and that results in 16 in this case. And if we have a negative raised to a positive exponent, no big deal. We can multiply negative 3 times. The negative is attached to that cube, or yes, to the cube. And so now we have negative, because I have 3 negatives, 27. And here it doesn't matter if it's a fraction either. We know that we can just cube the top and the bottom. So we know that this is, from our previous unit, this is 2 to the 3 over 3 to the 3, which is another way of thinking of it, though, is 2 over 3, 2 over 3, 2 over 3. So with fractions and multiplying, we just multiply tops, multiply bottoms. So we end up with 8 over 27, just repeated multiplication. So we notice that the positive exponent tells us how many times to repeatedly multiply the base. But what if we have a negative exponent? Okay, what does it tell us to do? So let's take a look at this one. 5 raised to the power of negative 3. Now again, this might be new, but what is this saying? Well, what it actually says is it tells us how many times to divide by the base, not multiply, but divide. Tells us how many times to divide, I'll put this in capitals, divide by the base. And this is always starting at 1. I'll explain in a second. Starting at 1. Okay, you must divide something, so you must sort of start with the identity of 1. So what does this actually equate to? Well, another way of thinking of it is I start with 1, okay, and then it's telling me to repeatedly divide by 5 3 times. So divide by 5, divide by 5, divide by 5. Now remember, we don't use this division symbol very much. I'm just kind of showing you in a linear fashion what that looks like. We would do this with a fraction. So starting with 1, and then I would repeatedly divide. So 5, 5, 5. So that's 1 being divided by 5, and divided by 5. And of course, we can rewrite that as just 1 over 5 to the power positive 3, because on the bottom here, this is just 5 times 5 times 5, which if we evaluated that, we'd get 1 over 125. Okay, so I want you to notice a couple things that happened. Let me switch colors. Really important is that we notice that up here we started with 5 to the negative 3, okay? And we went all the way over. I want to focus on what it looks like right here, okay? Put a little circle around this. What did we actually do? Couple things happened, okay? The exponent sign changes. Exponent, whoops. Let's just, whoa, hold on. Just trying to fix a typo. There we go. Exponent sign changed. Okay. Exponent sign changed from negative to positive 3. And then also the power is now on the bottom. The base is moved to the bottom. So power moved to the denominator, or the bottom, moved to bottom. So we don't actually have to show all this work. We can go right from 5 to the negative 3, follow my arrow to 1 over 5 to the 3 in one quick step. So that's what the law we're going to be using here. So that's what this example has, and we can do it both ways. So I want you to carefully look at this negative exponent law with integer bases, and I want you to notice that this is over 1 and this is over 1. Okay, is one way to think of it. But all that's happening is we take the power x to the negative n, and it moves to the bottom of a fraction. Okay, there is a fraction here. It moves to the bottom and becomes a positive exponent. If it's on the bottom, like in the second step, it takes the power and moves it to the top of the fraction. Okay, this one is not moving, even though it kind of looks like it, because there are ones on the top and bottom here. We're actually just moving the power x to the negative n. Okay, so let's take a look at a pattern here to understand what's actually going on. It makes us see things a little bit differently. 3 to the 3 is 27. 3 to the 2, 3 times 3 is 9. 3 to the 1 is 3. 3 to the 0 is 1 using our zero exponent law. But it might say, well, what do these actually equal? 3 to the negative 1, 3 to the negative 2. And I could write them in fraction format. Okay, so we know that that's the same as 1 over 3, or we could write that as 1 over 3 to the 1. Okay, this would be the same as 1 over 3 times 3. Okay, or just 1 over 3 squared. And we could also look at this last one, 3 to the negative 3, as 1 over 3 times 3 times 3, or 1 over 3 cubed. What's actually happening in each of these steps is it's just repeated division. So if I want to go up, I'm multiplying, but if I'm going down, I'm just dividing by 3 each time. So 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. And then we keep doing that division, and that's why the 3 is now on the bottom. It's 1 divided by 3. And then we divide it by 3 a second time, and then a third time. Okay, let's try a couple questions and wrap up this lesson. Okay, we're going to evaluate these. And so a lot of these answers are going to be left in fraction notation, and that's okay. We don't need to turn them into decimals for any reason here. It's not being asked to do so. All we need to recognize is first, we need to we're going to move our entire power. One way to think of this, and I'll show it a few different ways, is we're taking our power and we're applying the negative, or the negative moves this down. Okay, so I'm going to get a new fraction that I still have a 1 up on top. You can't have nothing there. There is a 1 sitting in front here. Okay, so the 1 stays up there. And then we move the 4 down and it becomes a positive exponent. Okay, this blue 1 did not move up. Okay, it stayed down there. I'm going to try to make this as clear as I can. But there are these hidden ones. There's a 1 up here and a 1 down here. Those still exist. Okay, we're showing it right here. Okay, so I'll go over this in class in a little more detail, but sometimes students think that the 1 is moving, but it isn't. Okay, we're going to see different examples where we'll have to look for that. So back to where we were here. Let's go back to red. Now all we got to do, now that we've moved it to the bottom, is cube the 4. 4 times 4 times 4 is 64. So our answer is 1 over 64. Again, let's do the same thing here. Let's just put it over 1. And we're going to move the entire power to the bottom, and that will get rid of the negative exponent. And now we can deal with multiplication. So now I just have to multiply negative 3 times itself twice, which is positive 9. So our result is 1 over 9. And in this case, we have our power on the bottom with a negative exponent. So we're going to apply that negative or move the whole power to the top. So right here, we're going to be shifting this up to the top. And so now I have 2 to the positive 4. It is over 1, but that isn't applicable here because it's 2 to the 4, which is just 2 times 2 times 2 times 2, which gives me 16. It's not wrong to say 16 over 1, but we don't require the 1 to be written. Now, sometimes we're going to take the negative exponent of a fraction, okay? And this is really easy to work with, because all it means is because the negative exponent is being applied to everything in the brackets, it's going to move anything on the top to the bottom and anything on the bottom to the top. So that's why we can see the A went down below and the B went up above. And now we have a positive exponent and we can deal with it no problem, because positive exponents are quite straightforward. Okay, so we're going to do exactly that. So first, what we're going to do is I'm going to show you this in two ways to give you options. So this, we can first just flip it right off the start. Okay, we can apply that negative, which is going to turn it into 4 over 5. And now it's being raised to a positive 2 for an exponent. If we do that, pretty easy. Now we just got to square both the numbers. I'll get 4 squared over 5 squared, which is going to give me 16 over 25, and then we're done. Another way to do it is just like we did before, is I can actually, there are ones on the 5 and the 4 as an exponent. We can multiply, okay, we can multiply here by the negative 2. So we get a new fraction of 5 raised to the negative 2 and 4 raised to the negative 2. Now in this step, I'm actually going to do two things at once. I'm going to take this power on top and shift it down, okay, to get rid of the negative exponent. And I'm going to take this negative exponent and shift it up to get rid of that negative exponent. So I'm doing two movements right now. The 5 to the negative 2 is going to move to the bottom to be 5 squared, and the 4 to the 2 is going to move up top. Now I have only positive exponents, and I'm going to get the exact same result of 16 over 25. You choose which ones makes more sense to you. I think the one on the right here is my favorite, because I really, as soon as I see negative exponents, I like to get rid of them as quick as I can. So that's my priority. So I'm going to do that with B here. And notice we have this negative here. Sometimes students get confused when there's a negative in the middle of a fraction, but just remember that if a negative is written in the middle, always move it up top. You can move it to the bottom, but it's going to make our lives easier if it's moved up top. Okay? So in that case, I'm going to be flipping this fraction, and it's going to move my negative to the bottom, but I can put that negative where I want. So let's see what actually happens here is I'm going to first rewrite it. I'm going to put the negative on top, raise it still to the negative 3. And now the negative is going to flip the top with the bottom, and the negative will disappear. So I'm going to have positive 4 on top and negative 3 on the bottom, all raised to the power of 3. And now I can cube both of those numbers inside. So let's do that. We have 4 to the 3 on top and negative 3 to the 3 on the bottom. Let's evaluate that. We're going to get 64 on top and negative 27 on the bottom. Now, we generally don't put our negatives on the bottom, so we could put it in the middle like before or move it up top. This is still an acceptable answer, but let's always put our negatives on top, get in that habit in our final result. Okay, now let's do some with variables. Now, this first one, you can put the whole thing over 1. So now you can see clearly, oh, there's a top and a bottom here. So right away, I'm going to remove this negative exponent. First, it says write with positive exponents is our goal. And we're going to simplify if we can with anything else. In this case, there's nothing to simplify other than moving it to make it a positive exponent. So I'm going to take this piece right here, and we're going to move that power to the bottom, and the negative exponent's going to be gone. We're going to be done. So I'm going to leave what's up top, 4y to the 4, and the x to the negative 2 moves down and becomes a positive exponent, and we're done. All right, on this one, again, a couple different ways. I'm going to move things to the bottom first. I don't like this negative exponent, so I'm going to use that to move everything below because it's attached to everything in the brackets. So there's just going to be a 1 left up top, and now I'm going to have 2x squared raised to the power of positive 3. And now we're just going to multiply. We're going to cube everything inside here. So we're just multiplying, and that's going to give us a new fraction. Let's go back to blue, of 1 over 2 to the 3, and x to the 2 times 3 using our power of a power law gives us x to the 6. And now we can rewrite that 2 to the 3 is 8, x to the 6. We have no negative exponents, and it's fully simplified. That's everything we can do there. Our last question here, couple ways to tackle this. But again, just get rid of negatives first and foremost. You could subtract exponents here, but you're going to be subtracting a negative. You got to remember your negative rules. Let's just take this guy right here, and we're going to move it up top. Okay, and then we won't have any more negative exponents, then simplify. So I'm going to still have the 5x to the 4 up top, and then that's going to also be joined with the x to the 5 from the bottom. Okay, there's nothing on the bottom anymore, so I don't have to write over 1. And let's simplify because we can have the 5, but we can combine these same base. We're going to add exponents, so I get x to the 9, and we're done. That's negative exponents. It's going to take some practice moving them around, but essentially think of it as just a switch to whatever it's attached to flip it from top to bottom or bottom to top, depending wherever it is. And then you have positive exponents, which are much, much easier. Okay, we'll see you next time.